We'll hear from all the speakers in turn, and we'll then open the floor for questions. But that being said, if you have a burning question during the talks, pop in into the chat, or raise your hand and jump in once the presentations wrap up. So I think the presenters requested to present together. So I'll take this opportunity to introduce all presenters. So the presenter from the industry is Michael Boye. He was the regional technical manager at Heidelberg Materials, Australia. He retired earlier this year. He has experience in manufacturing within the steel industry as well as in building products. This has involved technical support, working within a product development framework, line management, and project management. He has developed innovative engineering solutions that have significantly improved bottom line performance, as well as demonstrating effective leadership within a business unit of around 80 people. His specialties include project management, process optimization, waste reduction, driving financial performance, and driving a safe culture. So that everything that comes with running a big company, and is on top of it, and is and we hopefully listen from him at some point in time in the day.
Arun, Michael has just showed up.
All right, fantastic. Michael's here. So, and then Michael will hand it over to Associate Professor Son Vimonsatit. Associate Professor Son is from Macquarie School of Engineering, Civil Engineering Department. She received her bachelor's and master's of engineering in structural engineering from Thailand and her PhD from University of New South Wales in Australia. She has a broad range of experience in research and engineering practices in the construction industry. She worked as a practicing structural engineer for over 10 years in the design and construction of tall buildings, then worked as an academic at Curtin University for 12 years before joining Macquarie University. Her research interests are AI for material and structural design, buildability, construction materials, multi-scaling, structural engineering, and sustainability. And we have the final speaker, Professor Priyan Mendes. Everyone knows Professor Priyan, but for the sake of introducing him, I will run a few of his merits. Priyan Mendes is a professor in the Department of Infrastructure Engineering at University of Melbourne. He is the director of the ARC Centre for Advanced Manufacturing of Prefabricated Modular Housing and the leader of Advanced Protective Technology of Engineered Structures Group. He is the Deputy Director of the ARC Industry Transformation Research Hub, Transformation of Reclaimed Waste Resources to Engineering Materials and Solutions for a Circular Economy, and also the convener of the ARC Research Network for a Secure Australia from 2004 to 2011. He is a world leader in innovative construction methods such as prefabricated structures, tall buildings, durability of concrete structures, advanced materials for construction including waste materials, protective technology of structures, wind, earthquakes, fire, and blast. Okay, the boring part is out of the way. Now we'll get into the interesting part of the presentation. Without further ado, let me invite our first speaker, Michael Boye. The floor is yours, mate.
Yeah, thanks, Aaron, for the introduction. Can everyone hear me okay?
Yeah, you're good.
All right, great. Are you going to put the presentation up, Son?
Yes, Michael. Can you see that?
Yep, I can see it. You've got it in the non-presentation mode there, though. Are you able to swap the screens?
Is that better?
I can't see anything there now. Oh, there it is. Yep, that's good. Thank you.
Okay.
All right, so we're talking about a project that we did collaboratively between Heidelberg Materials Australia, Macquarie University, and University of Melbourne. So for those of you that don't know, CRC Smartcrete is one of the government's cooperative research centres. It's one of about 29 such centres. So Smartcrete is the one that deals with our industry, with construction materials. The idea behind the CRCs is that you collaborate with industry partners and universities, and the idea behind that, I think, is that the research becomes fairly commercially oriented right from the outset, which is certainly what I what I found in this project that we did. I think it worked really well. We were able to take it in a more commercial direction pretty much from the start. So I must point out that this project was more based around whether there's a kind of a commercial case to be met with graphene concrete. There's been a lot of work done already, particularly in the UK at Liverpool University. But the idea was, from a Heidelberg Materials perspective, to see if we could get reliable improvements in 28-day strength. And the idea after that was, if we could achieve that, to then look at other properties. We did look at some other properties, but the main focus was on 28-day strengths, since that is the main cost driver for the concrete. We'll go to the next slide. So the project team, as I said, it was Heidelberg Materials Australia, with myself as the industry lead. Rish Satsangi was the Materials Solutions and Innovation Manager based in Melbourne. Jonathan Capellis was the Regional Technical Manager in Melbourne. Priya Mendes, I think, as the introduction said, everyone knows. Thazitha Ganodara was the main project lead from a hands-on perspective from Macquarie University, and Saun was the project lead from Macquarie University. So we ended up doing most of the hands-on work down in Melbourne. I guess that's the great thing about working with a large organisation like Heidelberg Materials. We could have easily have done it in Sydney or Melbourne or Brisbane. We've got the facilities to do this sort of work all down the East Coast, as well as over on the West Coast in Perth. I think Aaron pointed it out, but I am now retired from my role with Heidelberg Materials, but still very happy to present this work. It's very interesting work, and we'll go through a few slides. But I must point out that there are a couple of papers that are published. So Thazitha Ganodara published a paper on this work called a comprehensive study of the macro scale performance of graphene oxide enhanced low carbon concrete. And one of the other researchers that was assisting has also published a really interesting paper, Pasadi Devapura, on the effect of graphene oxide on interfacial transition zone and strength enhancement of recycled aggregate concrete. So you can see from the outline, the project work was experimental based, conducted at the Melbourne-based facility of Heidelberg Materials. We focused on using commercial concrete mixers. We wanted to see if this would work with concrete material mixers that we were putting out in the market. We were looking at fresh properties, mixing methods, strength variations. We did some durability assessments, but at the end of the day, we were interested in was this commercially viable? Could we realistically expect to see repeatable improvements in 28-day strengths that would be commercially viable? And the idea is that the increase in 28-day strength leads to a reduction in cementitious content, which should allow us to afford to pay for the graphene oxide additive. Go to the next slide, please, Saun. So this was an idea of the concrete that we used for the trial program. So a mixture of 25, 40 and 60 MPa concrete. We tried it with ordinary Portland cement and slag, as well as ordinary Portland cement and fly ash. And we tried graphene oxide additive levels from 0.03 to 0.05%. So very, very low additions of graphene oxide. It doesn't take much. We used 2 different graphene oxide product suppliers. And you can go to the next slide, please, Sean. There's some pictures of the trial room down in Melbourne. There was some issues with slump retention that the university team were trying to get a handle on, and we managed to sort that out pretty quickly. We just had to avoid adding the concrete admixtures or pre-mixing concrete admixtures with the graphene oxide, because I think the graphene oxide was grabbing hold of it and not making it available for the concrete, for the cement. So when we changed the mixing sequence of the concrete additives, the graphene oxide additive, and water, we solved the slump retention issue, or the slump issues, and we were able to demonstrate that the graphene oxide certainly had no negative impact on slump retention. If anything, it might have actually improved slump retention a little bit. So as long as we got the sequencing right of the graphene oxide into the concrete trial mixes, we didn't have any issues with achieving the target slump or slump retention. Next slide, Sean. So what we did find, though, is when we got the workability and the additive timing right, we lost some of the expected strength improvements. They became unreliable, and Fuzitha did some work on PCE doses. So we were using the concrete admixtures to dissolve the graphene oxide, and you can see that there were very mixed results depending on the amount of the concrete admixture that was used to disperse the graphene oxide. I think what we were seeing when we got workability right is we were seeing inconsistent results in 28-day strength improvement, and we believe it was down to insufficient dispersion of the graphene oxide. So I think the aim of the game, in terms of getting consistent strength improvement results, is all about getting the dispersion right. So it really becomes a game about finding what sort of chemistry is going to do the job. And I must say, we didn't really get to that point during this one-year project. We got some results between 5 and 25% strength improvement, but we weren't able to achieve that consistently. So I think there's a huge potential here, but we really need to take it a little bit further and figure out what dispersion agents will get the consistent results. So this is just a slide on the different mixing methods. Just basically demonstrates the different methods that were tried, and mixing process 5, where you allow some of the concrete admixture, high range water reducer, you allow some of it to be taken by the cement and some of it to be taken by the graphene oxide. But again, a lot of it will come down to what dispersion agent is used. Next slide, Sean. I think you were going to do talk to the rest of the slides.
Yes, Michael. Yeah, thank you very much. I'm happy to do the rest if you want. Yeah. So hello everyone. Yeah, I'm Son. Thank you, Smart Grid CRC, for this opportunity to present, and also thank you, Arun, for the introduction. So the remaining part, as Michael has already mentioned, the mixes we've done, there were 3 mixes, the main commercial mixes with 3 different strength grades. So with that, we tried, like what Michael said, the main properties are the two key properties are the slump retention and the compressive strength. So we check that. So the test, I think that Michael, you correct me if I'm wrong. The compressive strength test, I think, done at your facility. Yeah. But some of the
correct.
Yeah, some of the durability tests were done at University of Melbourne. Okay, so first I'd like to present this. The control is a blue one. So we have the one without the graphene. And then we have the slum, as Michael already said, that we were happy with um, the coming up with the method, the sequencing mixing method that Michael mentioned, that managed to retain the slum and achieve, that was not able to achieve before. And then we tested at 4 days, 7 days, and 28 days. And then with the content of graphene oxide being like 0.03 and 0.05, and then we found that the best mix was with 0.05% of graphene in, concrete. At the 65 megapascal. So we managed to get about 25% increase, but that is only for that particular mix. And then that's why this one just still have a bit of variation when it comes to these results. So we have to look at how the whole thing, like in terms of the trend from the early strength to the 28-day strength. So this is what we've got so far. And then with the mechanical properties, then also we've done some durability properties, mainly at the University of Melbourne. And the first one being the rapid chloride permeability test, according to the ASTM C1202. And then basically it's just checking the Coulomb, charge, the passing, content, and according to this table. So the control has already quite a low or very low kind of, permeability passing. And then for the concrete mixed with graphene, also we find that it's very, very similar on the lower side as well. So these results are very promising that having the graphene in the concrete also can improve, even though slightly, but can still improve the chloride permeability, properties. The next one is about another test that we've conducted. It's a sorptivity test. You can see basically it's just like to prepare the samples and then submerge part of them in water and then check, the rate of water absorption by measuring the weight of the sample. By looking at this graph, you can see that based with the control and then with different time intervals, you can see that the control will show that quite like a quite a steady kind of increase in the water absorption, which when you compare with the mix with graphene, you can see that the trend is actually slower. The rate of water absorption and the weight increase is actually slower and dropping, as the time increases. So you can see the benefit of having graphene inside the concrete is also to limit the sorptivity or the water absorption. And that means that reduce the permeability of concrete. Yeah, and Michael has mentioned already a little bit about the one key factor when it comes to adopting new material and incorporating any new materials and while enhancing the properties and so on. So pricing is a very, very important and very critical. So we did a bit of study on a few graphene oxide products that we've incorporated in the test. And then we found that this kind of indicative price per kilogram of graphene oxide. And then you can see the different materials, they have a different range because you see, this kind of the development of these materials is still ongoing. So suppliers are also improving their kind of production and the methods. So that's why you can see the range and depending on the purpose and also the objectives in terms of the target properties of concrete. So when talking to suppliers, they are willing to work and by understanding what target properties might be, and then they can adjust or modify or their products, and that will also having some sort of cost impact. So that's why the cost has the range according to what you see in this table. So if you look at these different dosage, then you can see the added cost to concrete per cubic meter according to this table here. So we hope to see also some ongoing work on the price reductions from these suppliers. So yeah, for the project recap, then we have done some comprehensive assessment, as Michael was saying, that we have published a paper on that. We look at the performance, feasibility, and the commercial, application of graphene in concrete. And then even though because of some limited experiment and some issues that we encountered about this using the super plasticizer, the commercial super plasticizers have the impact on the mixing, the dispersion, and the quality of the graphene that we put in concrete. So there were some issues in that, and then we managed to solve certain issues, but it's still consistency in applying that is still a question. So we have to continue working on that. And then the key findings from this project, we like through Michael's help, we managed to improve the mixing methods and also to retain the slump and making sure that we achieve the workability of graphene concrete. And then obviously we, based on the results, we see that graphene have a very promising kind of benefit in terms of improving the strength and durability of concrete. And even though we need more research. Okay, so sorry. And then the last one being so a lot of work I think still need to be done on the development using different types of super plasticizers, and then to address the compatibility in terms of the dispersion of this material to make it commercially viable for industry. Yeah. So I think that's it from me. Thank you very much. So also I'd like to say something, if you don't mind. Michael already introduced about how this project started with the support from the CRC, the Smart Grid CRC. It's also with the collaboration, especially led by Heidelberg Materials. I also wanted to say something because the reason I was here being part of this project was the first discussion we had was at the Concrete, I think it was Concrete 2023 conference when we were in Perth. And then at that time, Michael was talking to Professor Priyan Mentis about this, potential of using graphene in concrete and so on. So I happened to be there in the middle of that discussion. So okay, why not we could develop, this project and then submit a proposal to Smart Grid CRC. So that's how it happened. So what I'm trying to say is that concrete conference like this CIA concrete conference is very, very good to attend. Then the upcoming one is going to be in September in about a couple of weeks' time. So I think, if anybody is interested, I think that's where we should go to. And then something like this could happen, a new collaboration. Yeah, thank you very much.
There's a shout out to all the academics out there who, if you are in for the next grant project, come to Concrete 2025. It's happening. It's happening, and Smart Grid's heavily involved with Concrete Institute of Australia. That's great. And I assume we are still waiting on Professor Priyan Mendes, correct, Natalie?
He's here.
I've been there from the beginning. I've been
Oh,
we missed you. We missed you, Professor Priyan. Yeah.
No, it's okay, Doctor. Thank you.
Yeah.
I can be very quick and be only. We want to really join the discussion, and acknowledgements have been made. But personally, I want to thank being in this graphene game for now 10, 12 years from the 2011. But then I stopped, and then first PhD student started in 11. But I got her to do a different project because he was, because at that time the hype went down a little bit. But then, anyway, she's a professor at the university now. But coming back to this, I want to first take 30 seconds to thank Smart Grid Claire, Hugh, Natalie, all the team for really being really helping this grant. Michael and myself, I think also just before even before that, Claire and myself did a low carbon concrete national seminar series. I remember meeting Michael when I had a couple of graphene slides meeting in Brisbane and talking about this initiative, and then we continued in the concrete conference. So it's really, and then also I have really had to acknowledge Dr. Son. I worked for so long now, and we're very close. Even we had done some very good work together, and for so long now. Anyway, coming back to this issue. So again, thank you to also to both SmartCrit and Mike and at that time Hansen, now Heidelberg, for supporting this project. Now, important project because I think so getting the commercializing the mixers, the commercial mixers is a key. We can do anything basically in the lab these days. So now with the lab to the field, which is the most difficult one, that's where in fact SmartCrit and Hansen supported me and so on. Also, I have to acknowledge Professor Wood. Also, he's here. He really supported right through this journey. And so coming back to this, with the lab we got with the super process, we have been using Glenium. We got okay, use names, but we have been getting consistent results. And even in a project trials I did for an infrastructure project here for durability, it worked very well with the Glenium. But then really the commercial mixes, which when we went to that, we found that the super process used was like not giving the same results like the lab. So that's why it's quite important. I got to also say that I'm continuing that work. We are continuing that work on the why this happened and going a bit more deeper into super processes and how that agglomeration. So I don't want to be too technical, but the reason for that is the graphene oxide reduces there are some technical people must be around as well, joining us, listening to us. So just for otherwise, just ignore. This is I know it's a general community presentation. Now it's because of the pH value, the acidity in fact increases and the pH value reduces with the GO slightly, not excessive, but that is the reason why that lead to, because concrete, as we know, is with more pH, higher pH, and in the concrete mixes. So that really is really one of the main reasons for this, what we call agglomeration and a slight reduction in the workability. So it's very, very important that we put these super processes. The PC range has given us more opportunities, but that's the work we are going to do a bit more. We are doing with, I got a chemistry, like no part-time postdoc, a couple of days a week, looking at it. It's already looking at this problem. We have been working on the workability, but not up to this level where we found out, and which we as I said, we could sort it out in our labs, but get into real commercial type of mixers, that's where I think so that's why we need to try and work on that. The second one I want to mention is the graphene, as Dr. Son also mentioned, this what was the cost was a issue which had been before. That's why I didn't even continue in 2011, 12. I couldn't get, but I had to really, here we are not naming any companies here, but one of the graphene suppliers that I work closely is really, in fact, supported this project, our work at Melbourne University, sponsoring even 3 PhD students as well. That company, really, that work, we did a bit of work with workability, and at that time we sorted out, of course, this is a huge opportunity to learn in the commercial mixes we use here. Other country was okay, I did that. But anyway, coming back to all this is that there's a journey, but it's a very promising material, as 3 of us mentioned today. And we will continue to have graphene oxide, and it gives, as Michael presented and then Dr. presented, this improves the compressive strength potential, but then also durability is increased. So this is I think we can match the wonder material title given to graphene at that time with the Nobel Prize and all that. So only thing is concrete, not many have done work, and we are probably the first to get the systematic. People are trying to use it around the world. I'm going to the Graphene Week, the main World Conference in like mid-September, whatever, third week. But we will know a bit more what other countries are doing. But we are one of the first to really get to this. So that's where we are, and we need to really also the mixers. That is again initial stages working with Mike. We in fact, I remember Claire also was really talking to us at that time about this cost thing, but we had the opportunity to really make it cost effective, and having the dosage, we can achieve anything with very high dosages with graphene oxide. But here we are not using all that. We want to be commercially competitive as well. So we have used a certain percentage, which really Mike has, the Hansen at that time was saying that to be competitive, we need it at a certain range. So that's what we had done. And that I think that way, I think it's a successful project. And then we found what has to be done. 1 year we can't do everything, but what has to be done in the future. Only other thing I want to mention is graphene oxide is a very much a material for concrete, which is easier than all the other. That's why we stopped working on other materials, because it's not, the reason is that it's not really like it can't be mixed properly, and it's and all that. So here we call it hydrophilic. That means water soluble. That is huge for the concrete industry because it is water soluble, and it's really like another type of admixture that can be used, water soluble admixture. So it's a lot of potential, and we will, as a team here, we will continue to really to be discussing this and then achieve what we want. We want Australia to really lead this effort. On using graphene oxide properly in a project. Other countries are trying, I know, but I think our knowledge is I think we got a good knowledge, and this project has really helped us as well to really get to a bit more the for real structures and all that in here especially. So thank you very much again, and I think I don't want to talk too much because I want to listen to people. So thank you.
I've been trying to just answer some of the questions in the chat, but if there's any other questions, happy to answer them. Oh, there's one here. Have you tried mixing geo directly into the PCE? I hope you're using polycarbonate ether-based superplasticizer, which is more compatible with graphene. So yes, we did try mixing it directly into the PCE. We had to withhold some of the PCE for the concrete mix. The original technique of mixing all of the PCE with the geo led to workability issues with the concrete mixes because the PCE wasn't available for the cement. We should point out too, we're talking about graphene oxide. So as Professor mentioned, the graphene oxide is relatively water soluble compared to graphene, which is more hydrophobic. And we've had a few questions on the source of the graphene oxide. So the sources we used in the project were from overseas, but there are some operations in Australia now looking to make graphene or graphene oxide as well. So lots of potential there, I think, to get the dispersion side of it sorted out. And I think once we understand how to do that reliably, it'll have a pretty large benefit. We got some questions about what sort of carbon footprint impact there would be, and I think given the very, very, very small amount of graphene that's actually needed, the impact by reducing the cementitious would if we get a 25% strength improvement on 28-day strength results, that should translate to about 10 or 11 or 12% reduction in embodied carbon, because we typically are using mixes with about 50% ordinary Portland cement. So yeah, pretty big impact if we get this right, and if we get it working consistently. There's a pretty big impact in terms of embodied carbon reduction.
Thank you very much, Michael. So I saw some questions, Arun, if I may. There's some questions about the form of graphene that we use. So we use a graphene in the form of graphene oxide, and then we use it. They are in liquid form. So what we use for testing, yeah.
I think
So we
I
didn't.
wanted.
Sorry, we didn't have to do any ultrasonic mixing because we want to keep it very practical and done in the lab. And so we just do, as per one slide that Michael has shown us, we just do like, a few mixing methods, mixing, pre-mixing graphene oxide with PCE, or, partially or fully and things like that. So we did a few trials on the mixing methods, and we didn't use any ultrasonic mixing for this particular test.
Maybe I might just add to that. Is it all right if I add one or two words on that? But I can't see the questions because I don't have access to for some reason, I'm meeting from the meeting room. I don't have access to the chat. But it's just to add to what Dr. Sean said. We are in fact adding for the graphene oxide powder can be used, but then actually has to be really ultrasonicated properly. We within the PhD project, one of the PhD projects, we did really look at all that the different mixing methods. I had to also acknowledge there's another very good PhD from Dr. Isuri from UNSW in Canberra. I was also part of that supervisory team. But that also, I'm sure there are a few papers around. She also did a lot of work on trying to look at the mixing. As we said, it's not relevant to this discussion, but too much. But the graphene oxide powder also can be used. But then the ultrasonication and other shear mixing, which we call it, we did try with different type of the speeds, and so that of course obviously improves, but that adds to the cost. So it's a bit of work have happened, but I think that's in some published papers also, that even from our broader work that you will see. So yeah,
I put some the titles and the lead authors up at the top of the chat too for a couple of the papers that are related to this project.
Yeah, Michael, I need to give a shout out to you. I think if there's a testament of how to be the manager in a big company running 100 people down the lane, 100 people in your team, and there you go. It's just answered all the questions even before we get to the question section, and done and dusted, and then you are off home at 5 o'clock kind of a thing. So I think it's a great testament. Even you got your skills going even after you are retired.
Exactly.
But
agree fully.
I think I want to bring this question up from Evan Smith. I'm sure Evan still it holds him is on the sustainable side of things. So I think he asked about the estimated 0.05% addition relative to the 400 kilograms of cement. Is it assuming a meter cube? Is it a total mass of concrete to 2,400 kilogram in a meter cube, or is the density is going to change with the addition of graphene oxides?
No, look, you don't get much impact in terms of things like density because you're using such small amounts. I mean, we'd only be using like 200 grams in a cubic meter of concrete, so it's almost in terms of the effect on density, it's almost negligible.
Yeah, and there was a question about
just to add to that one about I think the 400 times so it's 120 grams because per meter cube. 400 times 0.3% is 400 kilograms. Of course, we are assuming roughly 400 number for the cement. So 0.03% of cement weight, which is really 120 grams we were adding. So.
Yeah, depending on whether you're aiming for 0.03 or 0.05, it's in the order of hundreds of grams anyway. So very, very, very small amounts. So the idea that you can get potentially a 25% strength increase on your 28-day compressive strength, which with such a small addition of something is quite amazing.
Another question is is there a chance you could download the presentations to review? I think that's for SmartCreate, and these presentations will be sent across to all the registered participants, even if they are here or not. And that's an interesting question from Teresia James. What is the process of extracting the graphene oxide, and basically where is it coming from? I mean, is it very similar to the color oxides like titanium oxides, or is a very completely different process?
Am I allowed to answer that question, or maybe
Yes.
Mike can, Dr. Son, you can try first, but otherwise I'm happy to answer that question.
Well, I wouldn't dare comment on the production of the graphene oxide,
Yeah,
the extraction and all
So,
that.
because
Yeah.
this is an information session, I'll be very quick on this. It's really the graphite, which is really some of the graphites we were for this project. The company have been supplying, have been really getting from the purest type of graphites, which is 99.9 purity called vein graphite. And then the graphites are really going through, if you want to read modified Hummel method, that is there are a few ways of doing this, but this is the most popular and the most efficient method is called the modified Hummel method. And from that one, the Hummel method is the one that has been there, but now it's modified. Even the company made some modifications to that method to really, so modified Hummel method gives basically graphene as well. And the graphene has this, if you want to be a bit more technical, the oxides as well as I don't want to go deeper into that. Happy to discuss that another time. But with the oxides and all that, so oxygen is attached to that. But this some companies have done to reduce the cost is really get graphene oxide directly from those processes. So that's how the short answer for that one. But if you reduce it oxide further, then we get this reduced graphene oxide, which has some other applications. But for us, other thing which one of the companies which really we work mainly that company for this project, but other there but has done is to really reduce the cost by it's okay to give this information by rather than drying the powder, trying to get the powder, really take it out a bit more further, because something that I also had a say in this, but that is because we don't need the full purity for concrete. So what we have done in that with that company is to really reduce the cost by taking out the material before drying, so that that's why it comes as a paste, and that is not you can't use for batteries, but the graphene oxide is taken out before the drying process, and even before the oxides are really not taken out. So that's how the graphite oxide. So if you want to read a bit more, modified Hummel method. Yeah.
And there's another question on. I think it can be. The question was on any results in the carbonation depth with higher percentage of graphene in pozzolanic concrete mixes, but it can be combined with the initial technical explanation Professor Priyan gave about pH increasing higher pH of graphene concrete being higher than the normal concrete, and that probably led to chlor lower.
The pH was slightly lower, but it's a good question. Is that all right? Sorry, I'm actually jumping ahead of Mike and so on. Is that all right to answer the carbonation one? Because we didn't do any carbonation test here, but for in another way, we have done the carbonation test. So carbonation, as you know, we are even using carbonated aggregates these days, but that doesn't really affect the reinforcement level to take out the layer, the passivation process.
Passivity layer.
Passivity, yeah. Until which Dr. Arun, you have also done some in that area. But yeah, it's not enough to really just have any effect on the reinforcement. Yes.
Yeah. Okay. Yeah, and I think Michael and so on also replied in the message.
Yeah. Sorry.
No, that is okay.
Anything in the chat.
No, I directed it to you, Priyan. It's on me, if anything. I think that was a common question around these topics because we have all the experts here. Is there any work going on using biochar in concrete mixers?
It's not what this project was about, so
yeah,
I sort of might be a better place to answer that one from a pure research perspective.
Yeah. Because this question is there, biochar, if you see some papers under my name, there are other work, we're trying to use biochar in concrete, but it's really adds to a bit of carbon. So if you want to go a bit deeper, the LOI index increases a bit, where we have still put the limits, which is something I've been talking in the code committees as well. I think we need to increase our allowable LOI limit to really get a bit more carbon because it doesn't damage us because we are not in the core region. Anyway, that's for another day to talk about the LOI index thing. But so at the moment, the biochar will add a bit more. It will increase our LOIs to really high levels. So that is a bit of a problem. But otherwise, graphene oxide, biochar, even if there's a reduction in the biochar is carbon, it has not converted carbon. So there's some problem with increasing strengths to things. If there's any reduction, we can compensate with graphene. But then again, that you need to be conscious about the LOI index issue.
I think now that we have brought up LOI index and the standards and regulations, I'll probably have a question of my own. I think for all three presenters, you see any regulatory challenges or standard compliance issues for graphene oxide concrete, and or is it, or is it any new? Is there going to be a new regulatory challenge that we foresee?
I certainly wouldn't foresee it, Aaron. I mean, it's used in very small amounts and it's completely locked up in the concrete matrix. So I guess the only time when it might be liberated is when it comes to become recycled. But even then, it's very contained in the concrete matrix. So I wouldn't anticipate any regulatory concerns.
And
just a very quick addition to what Mike really answered very well, everything. Just that because graphene oxide doesn't really reduce any properties like other things that we have been talking about, have no reduction in strength, no durability issues. So there's no issue of, also it's just another type of like water soluble material we are adding. So it's no, but other discussions, I'll leave it for another time. But so again, as Mike answered this question, we had some discussions in Victoria trying to use it in a project, so didn't have any regulatory side, didn't have any. We didn't go ahead with that one, but still didn't have any problem.
There's a question that you're probably best to answer. Was the geosource in this research from pristine graphene or waste-based graphene? I'm pretty sure it was pristine, but over to you.
Yeah, actually, that's a good question, Mike, because I think because the carbon value you answered very well. The carbon value is with small quantity. So we had, as you know, we have done some carbon numbers and so on as part of this, but done some carbon numbers, so it's low. But in this case, there's plenty of graphite around to really, you don't get the same. There's some synthetic graphene as well, as we know, but you don't get anything closer to this. So to really get the properly, you need the pristine sort of graphite, yes. Graphite too, really, and it's not expensive. And also carbon, the processes that these companies have done, I know at least one company, but the other companies may be thinking also, but has been to reduce the carbon, really carbon footprint in the production processes. Special processes have been used.
Excuse me, Arun, I just want to go back to your previous question about the safety and regulation. And Smart Grid CRC is having another project which I'm part of. It's about looking at the technical guidelines of the high performance concrete, where we've got to look at the opportunity to put in graphene in that as well. So yeah, we're gonna review that existing standards and technical guidelines about these high performance concrete in general, and also when we have graphene inside as well. Yeah. So that is on Smart Grid CRC website, and people can have a look at the project outline in there. Yeah. It's with Transport for New South Wales.
Yeah. And another question from me would be, what are the potential applications that we foresee for this graphene oxide concrete? Is like a specific application focused use, or is it, if it takes off, is it going to be like completely like a general production via Heidelberg materials, any plant anywhere?
That's a good question, Aaron. And I guess the first question that we wanted to answer was, can it be a product that's used everywhere? And the answer really depends on whether the cost benefit is there. So if the cementitious savings more than offset the cost of the graphene oxide, then it makes sense to use concrete with graphene in it everywhere. And that was, I guess, the main question that we wanted answered in this first round of study with CRC Smartcrete. So if the answer to that was yes, then huge demand for the product. We could roll it out everywhere. If the answer was no, then it might be that the product would only be used in certain niche applications, depending on what sort of properties were improved by the use of the graphene oxide. As it was, we probably didn't really answer the question because we didn't get consistency in the results. So we really need to do a bit more work around how can we get consistency in the results by using the right dispersion agents.
Yeah, that's fantastic. And I think we have, thanks to Michael being active in the chat, we have almost covered all the questions that I can scroll through, and assuming we don't have any other questions, I think this is a good opportunity time to wrap up our meeting. And thank you for all the presenters who have gone way beyond what was asked of you to come here and present this amazing topic. Michael, Son, Priyan, so fantastic, and it's not just the presentation and all the questions that we've gone through. It was really good, and I felt, and thanks for speaking and sharing your thoughts around the evolving industry. All the best for the rest of the research, and at some point we'll see graphene oxide in the construction industry standardly used. I work for a precasters, or probably we'll get precast panels made and able to get it to the market. It's really interesting topic. Of course, you're pushing against the weight of regulations and capital, and it feels like a pushing a boulder uphill. For any follow-up questions or collaborations, please reach out to Smartcrete CRC. They'll make sure your messages get across to the right people, and you'll hear back. And this is from us today. If there's no questions otherwise, and thank you for being a great community, and enjoy the rest of your day. Thank you.
Thanks, Aaron. Bye, everyone.
Pleasure.
Thank you. Thank you,
Thank
everyone.
you. Thank you,
Thanks,
everyone.
Son.